All right, in this lesson, which is 9.3, the third lesson in our Unit 9 on volume, we're going to look at finding the volume of what we call oblique figures, specifically prisms and cylinders, which we've talked about previously. We're going to start with that, and then we're going to move on to finding the volume of composite solids, what that is, and strategies for finding those volumes. So first off, we're going to talk about oblique prisms and cylinders. When we have an oblique prism or cylinder, it's like our prism or our cylinder is leaning. So this is an example of an oblique prism. This is an example of an oblique cylinder. Now, the formula for finding their volume doesn't change. It's still the base area or area of the base times the height of the prism or cylinder. But what does change is how we determine height. So in a right prism or a right cylinder, those are the things that we've done so far where they don't lean, then the height is an edge measurement that goes from base to base in each of them. So it's part of the prism or part of the cylinder. But when we're dealing with an oblique prism or cylinder, our height still has to be perpendicular. See that right angle symbol there? So it can't be the sides because they lean. So our height in an oblique situation, we have to look for those right angles to get the correct height measurement. And it's especially important in case they've given us both. Like if we have a number 12 here and a number, 11 here, which one is our height? We have to know that the 11 would be our height because that's the one with the right angle. All right, so here is our first example. This is an oblique prism. It tells us it's oblique, but we also should know that from the fact that it is leaning. And so we've got an oblique square-based prism. And we know that for this oblique square-based prism, it says the height of this prism is 4 times the side length of the base. We're supposed to still find the volume. And for rounding, we're supposed to round to the nearest tenth at that point. That's the end of the problem. So if we have to do any rounding before that, we're going to go further than the tenths. Thousandths would be good, 2 more extra places. So here's what's a little tricky about this problem. So here's our right angle, which is saying that this measurement is our height h of our prism. We don't know that number. We just know that it's 4 times a side length of the base. So don't make the mistake of thinking that's 51 because this is a capital B. So this is base area. That's base area. And so that's not a side length. A side length would be like this measurement right here. Let's call it S. So what we have to understand, or we have to find first, is what is that side length so that we can multiply it times 4 to get our height. So we have to understand, well, how was that 51 area calculated? And that is based on the shape of this base, which is a square. So if it's a square, then it's a special rectangle where the measurements are the same. And so side times side, or side squared, would be its area. So we know then that this is S times S, or S squared, equals that 51 square centimeters. So the first thing we're going to do is find our S. So this is like our square root property. So we're going to take the square root of both of those. But this time we're only going to use the positive because a measurement, again, can't be negative. So we call this the principal square root, meaning that it is just the positive quantity, no plus minus here. So square root of 51, 51 is not a perfect square. So here's where we're going to want to use our calculators, and we're going to want to carry this out for best practice a couple of places beyond the tenths place where we round at the end. So like the thousandths, 3 decimal places. So let's take the square root of 51. And we get 7.141. So I'm going to make this the approximate symbol. And we're also taking the square root. So we're taking the square root of our 51, which is our decimal, and we're taking the square root of centimeters squared, which means our units are now centimeters, which makes sense. Centimeters times centimeters would give us that centimeters squared. So here's what we have for S. So now we can find our height by multiplying that S times 4. So we take our 7.141 times 4, and we get 28.564, and it would also be centimeters. All right, so now I'm looking at, I have my height. Now I'm ready to find the volume. So my volume, so second was finding height. Third is now actually finding volume, which remember, volume is base area times height. So best practice here, guys, would be to remember we already have a number to use for B. It was given to us, remember, as 51 square centimeters. That's not always true. But when it gives us that capital B, that base area, we should use it. So that means that we're going to use this 51 centimeters squared, and it's times our height, which we calculated as about 28.564 centimeters. So now we have centimeters squared times centimeters. That's going to be centimeters cubed, because we would take and add the exponents of 1 plus the 2. And that's our centimeters cubed. And then we take our calculator and multiply those numbers. And here's where we would round to the nearest tenth. So right now I have 1,456.764. So my 10th place I have to know would be where the 7 is. So I look at the 6 to decide, does the 7 stay a 7 or go up to 8? Remember, any numbers in that next spot that are from 5 to 9 mean the previous number goes up. So this is going to go up to an 8 this time, giving us about 1,456.8 cubic centimeters. And now I can write my conclusion, volume of the prism. So the volume of the prism and you can say oblique prism. That's might be even better, but it just said prism here, so that's apparently okay too, is about, because we're dealing with an approximation, 1,456.8 cubic centimeters to finish up the problem. All right, so here is a practice problem. You should have this practice problem in your notes. So I want you to take some time and work through this problem, and then we will take a look at the results. All right, so in this practice problem, we have to understand the first thing we have to do is find the radius, because we need the height for volume, and the height is 3 times the radius. We need that R value, that radius. So we have to start with the fact that our base area, capital B, is for a circle, and we calculate area of a circle with our pi r squared. So that's what this is saying right here. And then we divide both sides by the pi, giving us r squared equals 36 square centimeters. Then we square root each of those, giving us an r, or radius, value of 6 centimeters. So now our height becomes 3 times that 6 centimeters, which is 18 centimeters. Then our volume of base area times height becomes our B, our original B for best practice, 36 pi centimeters squared times our height of 18 centimeters, and then rounding to the nearest tenth, we get about 2,035.8 cubic centimeters. All right, let's move on to the next one. Oh, okay. So for this one, we're going to stop and do a little bit of prior knowledge first, which is going to be necessary for us in some of our problems. So here we're being asked to find the missing side of the right triangle. Hopefully you remember that if we have two sides of a right triangle, we want to find the third, we use what is called the Pythagorean theorem. And the Pythagorean theorem is a squared plus b squared equals c squared, where our c is always the hypotenuse. And remember that the hypotenuse is across from the right angle. So that makes the 10 inches our C, the hypotenuse. And for the A and the B, which are what we call the legs, so A and B are the legs, it doesn't matter which one's which. So I can make the 8 the A, or I can make it the B, does not matter. Okay, so now what I would do though to find X, which is the missing side, is I'd plug my X, my 8, and my 10 into this. So I have X squared plus 8 squared equals 10 squared. Then do my math and I get a 64 and 100. Then I subtract from both sides, giving me X squared equals 36. Now to get X, I have to take the square root. Again, this is the principal square root because measurements can't be negative. And so my X is 6, and its units would be inches because the 10 and the 8 are also in inches. So the missing side would measure 6 inches. So knowing this Pythagorean theorem and knowing when to use it, when you have to use it, is an important part from here on out in our volume problems. This is just showing the Pythagorean theorem for reference purposes. All right, let's take a look at this problem. So we have another oblique cylinder, okay, and we are supposed to find the volume of the vase in liters. So what we have to realize, in order to find the volume of the vase, which is an oblique cylinder, we have base area times height. This time we're going to have to calculate base area, which is area of a circle, pi r squared. So we need our height and we need our radius. Here's your right angle. So you have to realize this measurement is your height, not the 15. Okay, super important. And your 14 centimeters, that arrow is pointing to this measurement that goes all the way across the middle of the circle. So we have to realize that is our diameter. And so in order to find our radius, we're going to need to divide our diameter by 2. So that's one of the things we need to do, is find our radius, which is our diameter divided by 2. 14 centimeters divided by 2 is 7 centimeters. Another thing that we have to do is find that height. Here's where we have to realize we're going to have to use our Pythagorean theorem because we don't know our height, but our height is part of this right triangle that I am outlining in green right now. So here's the right angle. Remember, across from the right angle is our hypotenuse, which is C. So the 14 and the H would be like our A and our B. So our A squared plus B squared equals C squared is going to become H squared plus 14 squared equals 15 squared. And it's okay to use a calculator here. Some of these numbers, these squared values you might know, which is really good. Some of them you might want to double check with a calculator. Like 14 squared, sometimes I just don't have confidence if I haven't used it for a while, is 196. 15 squared is 225. Going to subtract. So H squared equals 29. And then square rooting, again, just the positive. So now I'm going to round, and my rounding at the very end of the problem is tenths. So I'm going to again carry this out for best practice and accuracy to the third spot, thousandths. So I get 5.385. The measurements here would be centimeters, just like the 14 and the 15 are in centimeters. So now I have an H value of about 5.385 centimeters. All right. So now I can find my volume because I have my radius R and then my height H. So third step, volume, which will be pi. Be careful that you don't accidentally mix up R and H because that would change your answer. So our R is the 7. So we're taking that 7 centimeters and squaring it and multiplying that times H, which is our decimal. Remember over here with the 7 centimeters squared that the 7 is squared and the centimeters is squared. So this gives you 49 square centimeters. And then your centimeters squared times your centimeters, that's what's going to give you those centimeters cubed. So now I'm going to take the pi times the 49 times the decimal and round. So now I would round to the nearest tenths. This one is interesting. So I've got 8 to 8.956 and so on. So if I'm rounding to the nearest tenths, my 9 is in the 10th spot. So I look at the next number, which is a 5. And remember, a 5 to 9 means that previous number goes up. So what does a 9 go up to? That if hopefully you remember that it goes up to a 10, which would change the 9 into a 0 and add 1 to the 8 to make it a 9. So this becomes about 829.0 cubic centimeters. And yes, you do need that 0.0 because remember, if you're rounding to the nearest tenths place, you need something in that spot, and that something is that 0. So now I can write my conclusion. So what are we doing here? We are finding the volume of the vase. Oh, in liters. So I can't write my conclusion. Darn. This is why it's always good to reread the problem. I don't have liters. I have cubic centimeters. And I should have known that because right here's my conversion to go from my cubic centimeters to my liters. So that is actually now step 4. We got a big problem here. So in step 4, we're going to convert. We're going to take our 829.0 cubic centimeters, which has a denominator of 1, multiply it times our conversion ratio. So we have 1 cubic centimeter. So we want that in our denominator to get rid of centimeters, is 0.001 liters, I think. And capital L is the abbreviation for liters if you want to use your abbreviation. So our centimeters cubed are going to cancel. And because of the position of the numbers, we will multiply them together. And now I'm getting about 8 to 9 liters. So now I'm going to round to this tenths, and that 2 means that 8 stays the same. So it's about 0.8 liters. So now I can write my conclusion. So the volume of the vase is about 0.8 liters. Here I'm going to spell it out just for clarity. All right. All right, so we have finished the portion of this lesson where we're dealing with oblique prisms and cylinders. And now we're going to move into the composite solids or composite figures. So here's our definition of a composite solid. It's a solid that's made up of more than one solid. So it can be a combination of prisms, cylinders, prisms and cylinders. So they can be different sizes and different figures. So it's just a mixture of different solids. If we want to find the volume of a solid, what we actually have to do is find the individual volumes and then add them together. So in this case, for this example, we have 3 cubes. And so we would have to find the volume of each of the cubes and then add them together to get the volume of the composite solid. So for this first cube, remember cubes, in fact, maybe you do, maybe you don't. Cubes are prisms. And so that volume formula, which is base area times height, their area is a square, so that's s squared, and their height is the same. And so the fastest way for a cube is to do s to the third power. So for that top small one, its volume would be 4 centimeters to the third power. And this would mean that we're going to raise 4 to the third power and the centimeters. So that becomes 64 cubic centimeters. For the middle cube, its dimensions are all 5 centimeters. So we would take 5 centimeters and cube it. So we cube the 5 and the centimeters. That gives us 125 cubic centimeters. And for the big one on the bottom, all of its measurements are 10 centimeters. So its volume would be 10 centimeters cubed. So we cube the 10, we cube the centimeters, and that gives us 1,000 cubic centimeters. And then we would add all of these together, which looks like it's going to give us 1,189 cubic centimeters. And now we can use that in our conclusion. So the volume of the composite solid is, not is about this time. We didn't do any estimating or rounding anywhere. The volume of the composite solid is 1,189 cubic centimeters. All right, so now let's take a look at this problem where, again, we're going to find the volume of a composite solid. This one is a combination of a cylinder, an oblique cylinder, because we can see it's kind of leaning, and a cube. So we have an oblique cylinder and a cube. And we want our answer to be in cubic feet, which is okay because the 5 and the 24 are both in feet. And when we're all done, it looks like we'll probably have to round. And usually that's because pi is involved. So, pi is involved with circles. And so anytime we're doing math with circles, we'll either have an answer in terms of pi, or we have to multiply that out and round. So here we're going to multiply that out and round. All right, so here we have to, again, do the volumes separately. So we need to figure out the volume of the cube and add that to the volume of the cylinder. That's going to be our total volume of our composite solid. Volume of the cube is going to be its side measurement cube. Volume of a cylinder is area of its circle base times its height. So these are the measurements we need. A side length of our cube, the radius of the circle, and the height of the cylinder. All right. So our 5 feet here, which goes from the center of the circle to its edge, that would be, by definition, its radius. So there's our R. So we know we have our 5 feet. That part is squared. Now, be careful here because if you are thinking that this h is 24 feet, you are not thinking correctly. Because if you notice, the h here of 24 feet goes from the edge of the cylinder, which is all the way at the top, all the way down to the bottom of the cube. So this is the height of both the cylinder and the cube. So now we have to figure out a way how to separate them. If you're thinking, well, just divide by 2, there's nothing in the problem that says that they're the same heights. If it said that they had the same height, then sure, dividing by 2 would make sense. But here, there's nothing in this problem that says that they have the same height. So we should not do that. So we have to be more strategic and mathematical about our thinking here. So how am I do you notice a relationship at all between this side or edge measurement of the cube and the diameter of the circle? If you're thinking, oh, they would be the same, you are correct. And so if we can figure out the diameter of the circle, we know the radius, then we can also use that for the side edge of the cube, our S measurement. So if our radius is 5 feet, then our diameter would be twice that, 10 feet. And that means our S is 10 feet. All right, so now we've got our S. This is going to be 10 feet cubed. The only thing left is our height h for the cylinder. So here's where we have to realize that, remember, this volume of the cube is S cubed, and that's because its height is also an S. So its height is a 10 feet. Well, if the height of the cube is 10 feet and the height of both of them is 24 feet, what does the height of the cylinder have to be? Well, it would have to be whatever 24 minus 10 is, which makes it 14 feet. So that's what we use for this h, would be 14 feet. So now doing our exponents first, this would give us 1,000 cubic feet plus pi times, remember the 5 would be squared here, 25 square feet times 14 feet. Now, the nice thing about your scientific calculators is that at this point, you can just type this into your calculator and it will do the order of operations for you. So you just type in 1,000 plus, hit the pi key, hit times, hit 25, hit times, hit 14, hit equals, and it will do the multiplication first and then add 1,000 to follow order of operations. And we can round that way. All right, so here I am getting 2,099.557 and so on. So if I want to round to the nearest 10th, which is where my first 5 is, the second 5 tells me to round that first 5 up to a 6, giving me 2,099.6 cubic feet. And now I can write my conclusion. So the volume of the composite solid is about, because we did round this time, 2,099.6 cubic feet. I'm going to spell it out this time. All right. All right, here's a practice problem. I would encourage you to pause the video give it a try, and then come back when you're ready to check. So here's what it should look like. So you have a prism and you have a cylinder. The first step is finding the volume of the prism, but it doesn't really matter which one you do first. And it would be length times width times height because it's a rectangular prism. And those measurements are your 7, your 13, and your 14, which, well, it doesn't really matter which one you call which. Maybe you call this your height and the 14 your length. And then the volume of the cylinder, we have our radius here of 2 feet. And remember that a height of a cylinder goes from base to base, circle to circle. So that 2 feet there is the height of the cylinder. So you've got pi r squared times height. And this is length times width times height. And then add them together and write your conclusion after you have rounded, in this case, to the nearest 10th. All right, so we want to develop our understanding of this concept here. So we have a pipe that is 2 concentric circles, or cylinders rather. That means that they have the same center. They have the same center. The inside or inner cylinder is hollowed out, so it's empty on the inside. Describe how you could calculate the volume of the solid pipe, which would be the part around that empty part. So if you are thinking to yourself that if you found the volume of the whole thing, the bigger cylinder, which would be the whole thing, and you subtracted off the volume of the smaller part that's hollow, that would be correct. Whoops, sorry. So you would subtract the volume of the smaller cylinder from the larger, or volume of the larger minus the volume of the smaller. And that'll do it. That'll leave you with the solid part that is the part around the empty part. So here's a practice problem that applies that. Again, pause the video, give this one a try, come back when you're ready to check your answer. So here, the volume of the larger cylinder, its radius is the 8 inches. So it's pi r squared, and its height is the 17. The volume of the smaller one has a radius of the 4. So it's pi r squared h. So it's the same except for use 4 for r. And then you have to remember to subtract larger minus smaller to get the solid part of the pipe, its volume. All right, here is another practice problem. Pause again, give it a try, come back when you're ready. Okay, let's take a look. So this one, you have a rectangular prism, like a box shape in the middle, and you have 2 pieces on the end that, remember, together form a cylinder. So you find the volume of the prism, which is in the middle, and you find the volume of the 2 end pieces, which is volume of a cylinder, and add them together. You do, however, need to, looks like, do some conversions here because you want cubic inches. There it is. So you want to convert everything into inches first, and then go ahead and calculate your volumes and add them together. All right, that does finish up this lesson with all of the problems, and I hope you have a wonderful day.